Hey guys, welcome back. Today we're going to be looking at activity 16.1. I'm Coach Williams or Mr. Williams, either way. And so I just wanted to kind of talk about what we're going to be doing in this activity. In this activity, we're going to be proving, for 16.1 is proving parallelograms, and then for the rest of activity 16, we're actually going to be proving different quadrilaterals, whether it's rectangles, rhombuses, or squares, okay? And so that's going to walk you through activity 16. It's going to be all about proving that shapes are a certain type, okay? Now, how are we going to do that? We're going to use the information that you learned in section 15, activity 15, okay? So that whole list of um, properties that you got for those quadrilaterals, you want to keep those handy as you're going through 16. It will help you a lot, okay? And so what I want to do real quick before we started on activity 16.1 is I wanted to review or remind you of some of the formulas and the things you're going to need in this section. So up here I have distance formula, midpoint formula, and slope formula. All of which are things from the past, all of which are things that you would have seen in Algebra 1, as well as earlier this year in geometry. But I just wanted to run you through kind of like the shortcut, if you will, the quick way that I think might help some of you to be able to work with these. So I'm going to give you two imaginary points. I say imaginary points, I'm just going to make them up. So we're going to go from 2, 3, and let's say 5, 7. Yeah? And we're going to find distance, midpoint, slope real quick, and I'm going to do it using basically kind of ideas instead of plugging in the formula and churning with the formula. Now, if you need to plug into the formula and churn with the formula, please, by all means do that. But here's just some real quick shortcuts for you. When I see distance formula, I'm thinking Pythagorean theorem. A squared plus b squared equals c squared, but we don't care about c squared, we want c by itself, so we're going to get c by itself. You take the square root. So a squared plus b squared, and then we take the square root of that. Well, what is A and what is B? A is going to be the difference in the x's. B is the difference in the y's. Okay? So how much space is there between 2 and 5? 3. How much space is there between 3 and 7? 4. So in reality, we're talking 3 squared plus 4 squared. So 9 plus 16, which is 25. Square root of 25 is 5. Yes, I picked one that comes out nice and pretty, but that was on purpose. I wanted you to notice that this distance was 3. This distance was 4. So when we're talking distance, really we had 3 squared plus 4 squared, and then we took the square root. And that's all the distance formula is, okay? I'm not saying you shouldn't use the formula, I'm just saying it can be done a lot faster mentally, all right? Midpoint. Midpoint is just the average. All you're doing is averaging the numbers. So if I were to ask you what's the average between 2 and 5, you would add them together, just like the formula says, and divide by 2. So 2 plus 5 is 7, divided by 2 is 3.5. So 3.5 comma, okay? Again, I'm not saying don't write out the formula and plug everything, and I'm just saying you might not have to. Okay, y'all are in geometry. Y'all are literally the smartest kids in the city. All right. 3 plus 7 is 10. Divided by 2 is 5. So bam, there's my midpoint. All right. Not a lot of work there, not a lot of stress. And the reason I'm highlighting this is because when you get into section 16, when you're doing activity 16, there's going to be a lot of slope, distance, and midpoint you're going to have to do. So the faster you are, the better. All right, slope. Let's talk about slope. All slope is the parts from the distance formula, okay? Notice this top part is the y values, the bottom part is the x values. So in reality, all we're talking about are these two numbers. We're talking about the y value going on top. In fact, we're gonna be talking about this fraction. The slope here is just 4 over 3. That's it, okay? You have to pay attention to the sign. Make sure, like in this case, they both went up, they both went up. If I had gone to a -1 here, this would have been a -4, and this would have been a -4/3 slope. It wouldn't have changed distance. It would have changed the midpoint, though, going from, let's see, that was a -1 there, going from 3 to a -1. Well, 3 plus -1 is 2, divided by 2 is 1. Okay, so that doesn't change the values that we used for distance because there's no such thing as negative distance. It changed our slope to a negative value, and it did change our midpoint. But notice how quickly we can adjust and deal with that. That's not a big deal, okay? Just to kind of play around with the numbers, you could change these numbers to anything you want. And if you're not comfortable with distance, midpoint, and slope, my suggestion is to you, honestly, make up 10 different points and find the distance, midpoint, and slope between all of them, okay? Practice, practice, practice till distance, midpoint, and slope is no longer an issue for you. So that when you're doing these problems in activity 16, you're not slowed up by the algebra because distance, midpoint, and slope are algebra, okay? And you should know that by now. So let's get to activity 16. Question number 1 in activity 16, they're giving us a parallelogram. Well, actually, they don't tell us it's a parallelogram. They just tell us that they give us these 4 points, and they basically want us to prove it's a parallelogram. The idea with activity 16 is that think of like finding the converse. Remember the alternate interior angles theorem with the parallel lines cut by a transversal, saying if the parallel lines are cut by a transversal, the alternate interior angles are congruent. And then we had the converse, saying that if the alternate interior angles were congruent, then the lines were parallel. That's basically what we're doing. In 15, we said, hey, look, it's a parallelogram, therefore the opposite sides are congruent, or therefore the opposite sides are parallel. Well, now we're going to go backwards. We're about to show that, hey, the opposite sides are parallel, therefore it must be a parallelogram. Okay? So let's go ahead and do that. I'm going to walk you through 1 and 2, and then I'm going to let you work a little bit on your own. On number 1, they give us 4 points. I've kind of drawn them up here on the board, but they are in your book. They are on the PDF file. They are on page 223 in case you want to follow along there. So they give us the 4 points. They ask us to find the slope. What is slope? Remember, it's the change in y divided by the change in x. So if I wanted to know the slope of hi, here's h, here's I. Notice it's a flat line. It is a horizontal line. I know my slope is going to be 0. So I'm going to go ahead and just write 0. In fact, if I notice CA or AC is a horizontal line as well, so my slope there is going to be 0, letting me know, hey, these two are going to be parallel to each other. Awesome. So AI and HC, what about the slopes there? Well, the change in y here is 5, the change in x is 2, so therefore my slope is 5 over 2. Well, if I go over here, from 4 to 6 is a change in 2, and from 0 to 5 is a change in 5. So notice I get 5 halves here, I get 5 halves here. So the opposite sides are parallel. All right? And so that would be, in B, it's saying, hey, explain why it is a parallelogram. Well, it's because the opposite sides are parallel. And that's the definition of a parallelogram. It's a quadrilateral where both sets of sides are parallel to each other. Okay? So hopefully that makes sense. Hopefully we're good there. We like that. Let's go ahead and talk about number 2. Number 2 is your first chance to kind of show something. This is an unofficial proof, which is basically what we're doing. And what we're going to show is that if the opposite sides of a parallelogram are congruent, if the opposite sides of a quadrilateral are congruent, then it's a parallelogram. Okay, I was getting ahead of myself a little bit there. So what they do is they start out, they tell us that SK equals IP, which I kind of drew on here with the single dots, and then KI equals SP, and so that is this side and this side. So that's what's marked in the drawing. You can mark it, just sketch the little graph on your paper there, or your drawing on your paper. My suggestion is for all the problems you do, draw a picture. The more pictures you draw, the more you notate your pictures, the better you're going to understand this. So in the first part of the question, in 2A, it talks about whether or not two triangles match up. It says, hey, this triangle is congruent to, and then it asks for the letters of the other triangle. I'm more worried about the fact, do you understand that the triangles should be equal? And if you do you understand why the triangles are equal? So let's get what they want, and then let's talk about what else is there. What they want to know is, they want to know what triangle matches PSI. PSI is short side, long side, not hypotenuse, sorry, short side, long side. And so if I'm looking at this triangle, going down the short side and then up the long side, that means I'm going to have KIS. And that's going to match up with PSI. Okay? Those are my triangles that are going to be congruent to each other. But for me, what I want to ask you though, what I want you to think about is why. Why does that work? Well, it's because they share this middle side. That middle side is shared. Remember that reflexive property that you learned a few weeks ago? Like last week, right? Reflexive property. SI, SB congruent to SI. Meaning that these two triangles match because of SSS. Alright? And so if you can see that, if your mind can get there, then you're in good shape. Alright? Now think back to the proof section. What do we generally do once we show that the triangles match? Then we talk about CP/CTC. Corresponding parts of congruent triangles are congruent. That's where these angles marks come in. Okay? What they're wanting you to do is to show that, hey, these angles match, and because these angles match, therefore the lines are parallel to each other. Alright? And so let's look at B. They have both sets of the angles there. And so what they're doing is they're showing this particular angle right here is going to match this angle. And this angle right here is going to match this angle. Okay? So that's what B is talking about. And it's because of CP/CTC that we can do that. Alright? So again, alternate interior angles. Here's your transversal. Okay, that's going to be your transversal. You've got one set of parallel lines here, one set of parallel lines here. So that's one set, all right? And then the other set is here. Notice the transversal goes through both sets, okay? So that's why you have two sets of alternate interior angles. So are the lines parallel? Yes. Why are the lines parallel? Converse Remember, you switch the order of alternate interior angles theorem. Now, what does the last part want? It wants you to come up with a theorem. And they've given you most of the verbiage there. They've given you most of the words. And so we'll see what it says. It says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a blank. It is a parallelogram. If both pairs of opposite sides are parallel, then the shape is a parallelogram. Okay? Hopefully that makes sense. What I want you to do now, guys, is I want you to go through on your own. You're going to do number 3, number 4, and number 5. Number 3, number 4, and number 5. Personally, I think that should take you 10 minutes or less. And when you're done with that, come back and see me. All right? Thanks, guys.